Of course, in these launches they do mathematical calculations, simulations and models, taking into account celestial mechanics, velocity, acceleration, orbits, gravity, among other things. All according to the spherical model and what this implies. So that in this case it can happen perfectly. That they do, and many people participate in these projects. Engineers, physicists, researchers, among others. The results of all that are precise and scientific, yes. But another thing is to bring it to reality, and that it could happen that way. They tell us that a satellite is in free fall towards Earth, but it does so fast it never touches the ground, then it goes into orbit. Of course, this is nothing more than a meaningless, unrelated sequence of words. With physical reality, free fall was associated with a decrease in distance to the center of gravity, and an increase in velocity, hence an increase in kinetic energy. None of this applies to satellites, therefore you cannot say they are in free fall. The idea of geostationary orbit satellites. It was popularized by science fiction writer Arthur C. Clarke in 1945, who helped fabricate trips to the moon and developed NASA's science fiction narrative as if it were real science. He was the author of science fiction works, such as the novel 2001, A Space Odyssey, and co-writer of the film of the same name. In this photo are Arthur C. Clarke and Stanley Kubrick along with NASA officials. Here we see some covers of books and magazines with space stations, satellites and ships fictional, invented and drawn by various science fiction artists. Before they will place the first satellite. Scientists are the most easy to fool, and there is a very good reason for this. Scientists study nature and nature never cheats, but some people do. Arthur C. Clarke. This is what they tell us officially: a satellite is not really in fall free, but is kept in orbit by centrifugal force, F equals mv2r, which counteracts the gravitational force F equals gmmr2. These two mutually exclusive little stories are enough to relegate them to the section of the library titled science fiction. But let's take a closer look. First of all, the ISS is supposedly a Colossus 420 tons operating in a gravitational environment of G equals 8.7 meters S2. That's just less than at sea level, so in terms of gravity, the ISS not in space still weighs 350 tons and an astronaut on a high space still weighs 160 kilograms. So how do you keep 350 T in the air? Or rather in space? Well, for those who have come to this question, there's another little ruse ready. Here we read, when a satellite is in orbit, it has a perfect balance between its momentum and Earth's gravity. To see through this trick, we would have to have been more than half awake in physics classes. First, two vectors at 90 cannot be at equilibrium, and then the momentum P equals mv would be 10 times less for the coupling capsule compared to ISS, but balancing the same severity. Second, the term momentum here plays with Newton's law of inertia, but this it is only applicable to rectilinear motion. Third, the constant rectilinear component in the motion of the projectile is independent of gravitational acceleration. And that means that even if the ISS were moving at the speed from the light, it would still crash in 5 minutes. After having circled many times, at a speed of 27,600 kilometers height, it would crash after less than 3,000 kilometers. Fourth, a motion where this equation F equals mv2r force. It is applicable, it is not free fall. It is not inertial behavior, it is propelled rotation. And that means that astronauts on the ISS, they would be glued to the rear of the capsule. The propelling surface of power, if we leave for now the question of who or what is driving the ISS. In this simulation you can visualize where the sheet represent the astronauts. They would stick to the back, to the wall of the capsule or station. Many here will say that centrifugal force, it is considered a fictitious force, but there are books that define it as follows. The apparent force experienced towards the outside of a circle is the centrifugal force. Is because the mass of the object resists centripetal acceleration inward that the object is experiencing. Newton's laws work in the so-called inertial frames of reference. There is no such centrifugal force. Nevertheless, something that revolves around the center of the spherical Earth is not an inertial frame of reference, but rather a rotating frame of reference. One thing is clear, a gravitational orbit inertial is as non-physical as it sounds, and it is only possible in the world of science fiction by Arthur C. Clarke or Stanley Kubrick, for example. So the International Space Station is not in space. The location in the one filming this movie set is probably somewhere in the States. Maybe Area 51, according to some. But many will say that the space station, it is real, because it can be tracked and you can see through its page where it goes to pass and go out to look at it with your own eyes or with a telescope. Well, they tell us that from one end to the other the station measures 109 meters. And in height it measures approximately 73 meters. Here a comparison with the size of a Boeing 747 airplane. In other words, the station is a little bigger than the plane. As seen here, it is not such a large object in relation to the sky. So they tell us that the station is between 330 and 435 kilometers within the Earth's atmosphere, and that it moves at a speed of 27,743 kilometers height. A commercial airplane flies between 10 and 12 kilometers of altitude. And see why this data is relevant. Here we see this video recorded by an amateur, who first verifies the ISON Live application. To know what day and at what time you will pass through your city that is in Holland. Because as many comment, yes, anyone can go out and record the ISS. It leaves at the indicated time and there it is in the sky. You see the light of what supposedly it's the space station. But seconds later another light appears, moving in the direction opposite and is identical, but this corresponds to an airplane. And it also moves at the same speed. Here another video where the station is seen. But at the same time other identical lights are seen that are airplanes, moving exactly at the same speed and looking the same size. What a coincidence. These videos were captured with a simple camera, probably from a cell phone. Here other similar videos. Many will say that you can see with glasses, telephoto lens or telescopes, and it shows that it has the shape of a space station. This is what amateur astronomers have captured. But there are also dubious images, which can be faked. Almost all astronomers or amateurs who have captured it, show something of very little clarity. And they are only some photographs or videos that sometimes appear until in the media, those that are seen with more definition. This is a photograph of a jumbo jet with the moon in the background. Here is a comparison of the station also photographed with the moon in the background and the plane. Here you can see that this station is almost the same size, just a little smaller. Besides, if you compare the station in the photo with its supposed design structure, only the solar panels match. The other parts of its structure are missing. Remember, the space station is a little larger than a Boeing 747 plane, but this, according to the official, is 400 kilometers from altitude and a commercial airplane flies at only 10 kilometers. Compare two objects almost the same size, but one at 400 kilometers high and another at 10 kilometers, it is quite the difference altitude, but both look and move the same. At that altitude, the space station, it should not be seen in the vastness of the sky, or it should not be seen from the same size and intensity than a commercial airplane, nor move at the same speed. A commercial airplane travels at 800 kilometers height and the station at 27,000 kilometers height. It is an abysmal difference. The space station captured in those videos and photographs, it is not at all 400 kilometers. They tell us that the space station only moves west to east across the night sky for only a few minutes at most before it becomes invisible. The problem is that the station has been seen going from west to east and also from east to west. What is captured in these images can be from an airplane, a special drone, or another type of flying object made specifically for this purpose. With all the budget they manage, they can do anything. The International Space Station was designed like a long stick with no aerodynamic structure and to have the shape inside of a jumbo jet, where they do the astronaut shots. Then they added some solar panels and voila! If they were there, instead of doing pirouettes, juggles and shows in windowless locations, astronauts should be much of the time showing what the Earth looks like from that distance. Zooming into places and cities and see the movement of everything that happens down there in real time. And share to the world how things look from that distance, from space. But to date there is not a take, live and direct that shows, for example, what life looks like happening upside down or sideways, in places like Australia, Patagonia, South Africa, Antarctica, or anywhere else. It costs NASA $3 to $4 billion a year to operate the International Space Station. With only part of that budget, they can do many things to make people believe what they want. But at the same time, if we analyze, we can find errors and inconsistencies. Because all this, it is made by human beings.